Okay, good afternoon, students. Welcome to this class. I'll be taking gravitation. As at 1665, Isaac Newton noticed that when a body falls from a given height, there must be a force or something in nature that acts towards that body for it to react that way. Okay, and with time he was able to come up with what we call the Newton's law of what? Gravitation, which states that everybody in this universe attracts every other body with a force that is directly proportional to the product of its two masses, but inversely proportional to the square of the distance separating these two bodies. Mathematically, what he's saying is that F is directly proportional to, let's say the two bodies are m1, m2 by what? R squared. Bringing in the proportionality constant, we have that F is equals to G m1 m2 by R squared. This is the Newton's law of gravitation. Okay, let's get the unit for this gravitational constant G is Fr squared by m1 m2, giving us Newton times meter squared by kilogram all squared. So using the unit analysis here, we have these two, Newton meter squared per kilogram squared. This is the units. And this gravitational constant is a constant that has the value of 6.67 exponential minus 11 Newton meter squared per kilogram squared. And if you can still remember, on this earth, on this universe, the force of gravity or that of weight is equals to mg. All right, and let's say that these two bodies are equal. That means you have a uniform mass, means that m1 will be equals to m2, which we can take as m. So that is to say that the gravitational force is going to be g m1 m2, they are the same, m squared by r squared, and the force on the weight is mg. When we equate both, we'll be having g m squared by r squared to be equals to what? Mg. We can cancel one, and then we have that our gravity is equals to gm over what? R squared. Please, let's not forget that. Moving ahead, we also have what we call the centripetal force. Okay, the centripetal force Fc is equals to mv squared over what? R. We can also relate it with this. Okay, let's say that this is an orbit. This is an orbit, and there's an inward force that is holding this body from escaping from this orbit. Alright, if we say that this Fc is equals to Fg, we are going to have that mv squared over r will be equal to what? Gm squared over what? R. So cancel the mass, cancel one of the mass here, cancel the radiuses here. We have that our v squared is equals to gm over what? R. Remember, this is protecting this body from escaping from the orbit. So the type of velocity that we have here should be the orbital velocity. And this orbital velocity is now equals to, I'll take the square root of this and have gm by r. Now, provided that this is not acting at a given height, if it's acting at a given height, our total r becomes r plus h. This h is when it's acting at an altitude outside the surface of the earth. Okay, moving ahead, we can also relate and remember when we talk about the velocity that a body needs to escape the surface and orbit. It can be the earth, it can be the moon. All right, we call that an escape velocity. And if you still remember from your elementary knowledge of motion, we have that v squared is equals to u squared plus 2ax, right? In this case, since we are talking about a circular body, the distance s is what? Radius. The distance s is equal to what? Radius. So in that case, that now becomes, from equation of motion, u squared plus 2. So the distance is what? R. And the gravity is that of the of the earth or the universe. So in that case, let's say the body is coming from rest. Initial velocity is 0. So v squared becomes 2gr. And this escape velocity becomes 2. This is what we call escape velocity. And I just want to tell you something. The difference between the escape velocity and orbital velocity is the constant 2. So orbital velocity is also equal to what? Gr. Please don't forget that. Next is when we are talking about force. Generally, you've known before now that force in a circular motion is equals to what? M omega squared r. Because force is generally what? Force is generally mass times acceleration. And in a circular motion, acceleration is omega squared r. So therefore, the force will be m omega squared r. And you remember that the angular velocity omega is equals to 2 pi f. And frequency is the inverse of what? Period. So that can be written as 2 pi over what? T. Substitute that here, we have f to m 2 pi over period all squared r. Giving us, this square will give us 4 pi m r by what? Period squared. Alright? So in essence, force is equals to 4 pi squared mr over what? Period. Okay, so please let's look at questions. Let's look at questions. Let's address the questions here on the board. Calculate the force necessary to keep a particle of mass 0.5 kg moving in a horizontal circle of radius 1.2 and a period of what? 0.9 seconds. Now there is an equation which I've stated here that relates radius of the body, its period, and the given mass of the body. The equation is that F is equal to what? 4 pi squared mr by what? Period. Now in this case, we have 4 pi squared times the given mass is 0.5 and the radius is what? 1.2. And we divide it by 0.9 seconds squared, right? Seconds squared. Okay. 0.9 seconds squared. Please don't forget this. Okay, so when you punch your calculator, 4 times pi squared times 0.5 times 1.2 divided by the square of 0.9, you'll be getting 29.2 newtons, because unit of force is in newtons. Next, a body of mass 0.2 kg is wide round a horizontal circle by a string inclined 30 degrees to the vertical. Calculate the tension in the string. Calculate the tension in the string. Okay, so let's take that calculation. This is the body. Let's say that this body is here, it's wiring round. Okay, the weight of the body is going to be acting downwards, which is mg. So I'll take it as weight. The centripetal force is going to be acting here, and then there will be tension in the string. Is that not true? There will be tension in this string, and it's attached to an angle theta. So we've been asked to determine what and what. We are given theta. We are asked to determine the tension in this string. Now pay attention. So one can easily see that this is tension, while this is the weight of the body, while this is the centripetal force, right? And this is the angle theta. Okay? Now that you have the mass telling you you can get the weight of the body, and you have to get tension. So we are trying to relate this with this. So what is the relationship? This is theta, this is the hypotenuse, this is the adjacent. That can only be what? Tan theta will now be equal to what? 2 opposite for centripetal force. Then if I take cos, that is adjacent hypotenuse. Cos theta is what? Adjacent, the weight, over what? Hypotenuse, the tension. In essence, we are looking for tension. Tension becomes what? Weight over what? cos theta. And you know since that weight is mg cos what? Theta. And what is the weight here? The mass is 0.2 times 9.8 cos 30 degrees. Cos 30 is 0.866. You remember? If we have 0.2 times 9.8, then we have cos 30. And that will give us 2.26. We have 2.26 newtons. Alright, so let's look at the third question. You understand it? Let's look at the third question. The third question states, what is the speed of a satellite in a circular orbit just above the surface of the Earth? It's very simple and straight. Orbit, meaning orbital velocity, that's what they're asking, or the orbital speed. And I've told you before that the orbital speed is equal to the square root of gm by r, which can also be the square root of gr. Now we are given what? We are given radius and we are given gravity. So we use the second relationship that states that the orbital speed is equal to the square root of gravity times radius of the Earth. And that will be giving us, we have the gravity to be 9.8 times 6.4 times 10 raised to power 6. So when you use your calculator, by the time you punch the calculator times 6.4 exponential 6 square root this answer, you'll be having 7919.59. So this can be approximated to 7920. Convert it to standard formula 1 to 3, meaning 7.92 times 10 raised to power 3 is velocity meters per watt seconds. And that goes to number 4. Number 4 says, suppose that divine runs along the circular part of diameter 200 meters in 50 seconds. What is the average speed? You remember today that average speed is equal to the total distance over the total time taken to cover this distance. In a circular part, what is the total distance? Let's say this is the circular part. You start at this point A, you move. While you are moving, the total distance you have traveled is equal to the perimeter of the circle or the circumference of the circle. So in this case, the average speed is equal to what? The circumference of the circle, which is 2 pi r over what? The total time. The time to complete a cycle is called period. So what was given to us? We have diameter. Radius is equal to diameter over 2. That means 200 meters over 2 is equal to 100 meters. That's the radius. Then period is 50 seconds. So we now have 2 times pi, which is 3.142, times the radius is 100, divided by the time, 50. So cancel, you have 2 times 2, you have 4 pi. And pi is what? 3.142. So 4 times 3.142 is going to give you 12.57. So we have 12.57. That is velocity meters per second. And that is option what? D. Alright. So thank you, class. This is gravitation. So I want to see you all in our next class at kinematics tutorials that is located at Ekosodi Back Gate. Thank you.